Greetings, tutors. This is Cycle 3, Week 21. For Hands-on Science, we're going to be looking at combinations in probability, and we're going to be using pizza toppings. So the base experiment of this goes with 3 pizza toppings. I have 3 templates that you can choose to use for that. We have these empty pizza slices with the answer key to go with it. Those can be used, these ones should be passed out to each student, and then they can have a picture of all of the choices to take home with them. The next choice that I found is this page, where you're supposed to color in the pizza toppings, cut them out, and then use them to put on the pizza to show different combinations. This one would require you to keep track of the combinations on a different sheet. So what we can have for that is either this table on the back of Nicoleum or this table that goes with the discussion guide that Rachel sent out a few weeks ago. So I'll have a few copies of each of these available, and you can let me know which ones you choose if you do. The last choice for 3 combinations is this. So for these type, I have some stickers which would look kind of like this. You can take the stickers and have them just make a key that shows which sticker equals which topping if you want, and then stick them on like that. Or what I decided I liked better was just to use a colored pencil like this one and draw your toppings in. Kind of makes it look more like a pizza, I thought, a little more interesting. So those are our 3 topping choices, and you can let me know which one you like the looks of if you have a preference. What I've done already is made enough copies of each of these to accommodate 1 class. So if you show up, there will be something to use, but if you prefer one, just let me know and I will make sure you have enough of the one that you want. For the older classes, I would suggest maybe using this sheet, which will accommodate 3, 4, or 5 toppings. So what you can do is see how far you get in class, basically. I think some of you might have time to fill this all out in class, but if you don't, you can always go up to the 3 toppings or the 4 toppings and then send this home for kids to figure out on their own. So right now I do have enough copies of this one to accommodate the 3 older classes, but if any of the younger classes would like to do this and say do the 3 toppings in class and then send this home for anybody more interested, that's also fine. Just let me know. I have a couple notes on the math formula as well that you can use to figure this out. So it might be kind of fun for older classes to just see this on the board, how you might figure out if you had more combinations than just the ones that you can record on a paper. So I'll try to explain this to you guys. Up here on the top is the formula. I have the different things that each of these letters is supposed to represent. So what happens here is the N is the number of toppings you're going to be working with. If you're going to do just the 3 toppings, then your N is going to be 3. That means that your R is going to be the number of toppings that will be on each pizza. So you can see from this chart that there is a number of 1 topping choices, 2 topping choices, and so forth. So what you do with the formula is you plug that number in as R. You will want to figure out with these formulas here how many one topping options there are, how many 2, and how many 3. So if you go on, you can see that this one I did for 5 topping pizzas. That would replace the N on top with a 5, and then you would do the same thing, but with 1, 2, 3, 4, and 5 now. And I got these answers. The number of one topping pizzas would be, pretty obviously, 5. This is where it gets a little more tricky, but you can see that the 2 topping options, there should be 10 of them. The 3 topping options, there should be 10. The 4, you should come out with 5. And the 5 topping, obviously, it has all the toppings, so there's only one choice for that. And this paper that I made actually has that. Whoop, that's actually the old one. This one has a couple extras, but what I did, last time I did this, I wasn't quite sure how many options there were, so I ended up leaving a few extra to see if anyone was able to find any more. After I did the math, I decided to alter the sheets so that each column actually has the proper amount of pizzas. So if you go up to 5 toppings, you will know that you've got all of your combinations when all the pizzas are full. So just a little more on this formula. I was a little confused about how to use this exclamation point, so I found that an exclamation point in math means a fractional operator. So this is how you use a fractional operator. This is the example. If you had, we don't actually have a 7, I don't think, but if you had a 7 with an exclamation point, it would actually equal this multiplication. And you will find on this last one here that 3 minus 3 equals 0. So this is where I got into trouble. Anything times 0, of course, is 0, which doesn't make this come out right. So I did a little more research and found that a 0 fractional operator actually equals 1, not 0. So that will make this math come out correctly. So I'll bring this paper for you guys to look at if you need it, and I'll make a couple of copies if you want to do some of this math in class so that you can follow along. So again, if you have a preference of which paper you would like, just let me know. I will have enough copies of something for each of you to use these, but if you want one in particular, just let me know and I'll make sure I have enough of that one. Thank you.